Hello everyone, welcome back to online class. I am Akkamahadevi from Upper Public School, Kalaburgi. So today I am here with the same chapter, Fun with Magnets. So before starting this class, let us recall what we have learned in the previous class. Okay. So in the previous class, we have learned about magnet. So what do you mean by magnet? Yes, objects which attract magnetic materials like cobalt, nickel and iron are called as a magnet. Okay. So there were two types of magnets. One is natural magnet and another one is artificial magnet. So what do you mean by natural magnets? Okay. So here the magnets obtained naturally from a magnetic rock are called as the natural magnets. Okay. And the example, magnetite. So magnetite is a big rock. Okay. So it is an example of natural magnets. So next is artificial magnets. So what do you mean by artificial magnets? So here, those magnets prepared by the combination of certain mineral ores are called as the artificial magnets. Okay. So there are different types of artificial magnets which are classified based on their shapes. Okay. So which are those shapes? Let us see. Yes. So here, this is a bar magnet, cylindrical magnet, horseshoe magnet, and this one is ball-ended magnet. Okay, so these are the magnets of different shapes. So next even we have learnt about magnetic and non-magnetic materials. Okay, so what do you mean by magnetic and what do you mean by non-magnetic material? Let us see. So magnetic materials. So here materials which are attracted towards a magnet are called magnetic materials. Okay, so here the materials which are attracted towards a magnet are called magnetic materials, and the examples are iron, nickel and cobalt. Okay, so even we can see lots of examples here. So here is knife, which is a magnetic material, isn't it? Coin, spoon, nail, paperclip. So these are the examples of magnetic materials. Okay. So next is non-magnetic materials. So what do you mean by non-magnetic materials? Materials which are not attracted towards a magnet are called non-magnetic materials. Okay. So here the materials which are not attracted towards a magnet. Okay. The examples are aluminium, zinc, wood, rubber. Okay. So even we can see lots of examples here. Okay. So paper, it's a non-magnetic material. Glass, it is a non-magnetic material because it will not attract to magnet. Even plastic, rubber and even wooden chair. So these are the examples of non-magnetic materials which will not attract to magnet. Okay. So next even we have learnt about poles of a magnet, isn't it? So magnetic materials get attracted towards the end of the magnets. So these ends are called poles. So how many poles are there? Yes, there are two poles. One is North Pole and another one is South Pole. So here even we have learned like iron fillings will attract only at the end of the magnet, that is to the poles of the magnet. So even you can see in the horseshoe magnet also. See how iron fillings are attracted to the poles of a magnet, that is North and South Pole. Okay, fine. So today we will discuss about finding directions. Okay, yes. So magnets were known to people from ancient times, right? You might have read many interesting stories about the uses of magnets. One such story is about an emperor in China named Hong Ti. Okay, yes. It is said that he had a chariot with a statue of a lady that could rotate in any direction, as you can see in the picture, isn't it? So it could rotate in any direction. So it had an extended arm, as it was showing the way. Okay, the statue had an interesting property. So what is that? Let us see. It would rest in such a position that its extended arm always pointed towards south. Okay, so by looking at the extended arm of the statue, the emperor was able to locate directions when he went to new places on this chariot. Okay, so he used to find direction by using this statue. Okay, so now let us see one more activity to find direction for ourselves. Okay, so now we can't use this statue and all. So nowadays, how we can find the directions? Let us see in the next activity. Yes, so here you can see a magnet, you can see a thread, and even you can see a stand. So now we will see what we can do in this activity. Okay. Yes, so first for this activity, what we should do? Take a bar magnet. Okay, so take a bar magnet and put a mark on one of its ends for identification. Okay, now tie a thread at the middle of the magnet, as you can see in the image. Okay, so you should tie a thread at the middle of the magnet so that it can be suspended from a wooden stand. Okay, make sure that the magnet can rotate freely and let it come to rest. Okay, mark 2 points on the ground to show the position of the ends of the magnet when it comes to rest. Okay, draw a line in which magnet was pointing in its position of rest. Okay, so now again rotate the magnet by gently pushing one end in any direction and let it come to rest. Okay, so again mark the position of the two ends in its position of rest. We will observe that a freely suspended bar magnet always comes to rest in a particular direction, which is the north-south direction. Okay, so all magnets have two poles, whatever their shape may be. Usually north and south poles are marked on the magnets, isn't it? So this property of the magnet is very useful for us. For centuries, travelers have been making use of this property of magnets to find directions. It is said that in olden days, travelers used to find directions by suspending natural magnets with a thread, which they always carried with them, isn't it? So here you can see, you can test by suspending this magnet, you can see always it comes to rest, that is in the north and south direction. So we can easily find out the directions, isn't it? Yes. So later on what happened? A device was developed based on this property of magnets. So it is known as the compass. Okay. So here is a magnetic compass. See here, a magnetic compass. A compass is usually a small box, isn't it, with a glass cover on it. A magnetized needle is pivoted inside the box, which can rotate freely. You can see a magnetic needle inside the box, isn't it? It also has a dial with directions marked on it and keep at the place where we wish to know the direction. So now what we should do? It also has a dial with directions marked on it, isn't it? And is kept at place where we wish to know the direction. Wherever we want to know the direction, we can keep this compass. So its needle indicates the north-south direction when it comes to rest. Okay. So when it comes to rest, it shows the north and south direction. Okay. The compass is then rotated until the north and south marked on the dial are at the two ends of the needle. Okay. So identify the north pole of the magnet. So now you should identify which is north and which is south, isn't it? So what we did, like to identify the north pole of the magnetic needle, it is usually painted in different color, isn't it? So you can see here red color. So we can identify that it is a north. Okay. You can see here is on the compass north, south, east and west, isn't it? So when we find north direction, is it possible to find us east, south and west? Exactly, we can find. So if we come to know any one direction among this, so we can identify all the other three directions. Okay. So here magnetic compass, it shows north and south direction when it comes at rest. Okay. So this is about magnetic compass. So next is make your own magnet. Okay. So how can we make own magnet by ourselves? Okay. So for this, what you should do? So as you can see on the image, okay, what are the things they are using? So just I will tell you. So take a rectangular piece of iron. Okay, so you should take a rectangular piece of iron. Place it on the table. So you should place iron piece on the table. Okay, so now take a bar magnet. Oh, you should take a bar magnet and place one of its poles near one edge of the bar of iron without lifting the bar magnet. You should not lift the bar magnet, just you should go on rubbing. Okay, move it along the length of the iron bar from which we began. Okay, so where we began, from there we should go on rubbing. Okay, move the magnet again along the iron bar in the same direction as we did before. Okay, so repeat this process about 30 to 40 minutes. Okay, so to make a magnet, what we should do, we should rub this magnet to iron for more than 30 to 40 times. Okay, so bring a pin or some iron fillings near the iron bar to check whether it has become a magnet or not. Okay, so if it become magnet, fine. If it won't, like it is not become a magnet, then what we should do? Yes, if not, you should continue the process for some more time so that iron will turn to magnet. Okay, this is how we can make magnet. Okay, yes. So here is one more activity. Okay, so how by using magnetic needle we can show like directions by using a magnetic needle. So let us see this activity. So again, for this activity, what are the materials we need? We need plastic like jar, we need water, isn't it? We need cork, we need like a needle which is of magnetizer. So first, before taking needle, what we should do? We should magnetize that needle. Okay, so what is the procedure? So like what are the, like what we should do for this? Let me tell you. Okay, so first what you should do, take an iron needle. Okay, as we took here, this is a iron needle, and turn it into a magnet by using a bar magnet. So as I said earlier, so just before I said like how to make a magnet, own magnet. So same you should do here also. You should magnetize this needle by using bar magnet. Okay. So now insert the magnetizer needle through a small piece of cork or foam. So you should insert the needle in a cork or a foam as you can see in the image. Okay. So now let the cork float in water in a bowl or a tub. Okay, so let the cork be float on the water. And you should make sure that the needle does not touch the water. Okay, you should take care that the needle should not touch the water, because if the needle touched the water, then it loses its property, isn't it? So you should make sure that the needle does not touch the water. Okay, your compass is now ready to work. Okay, so always we will find that when the cork stops rotating, the magnetized iron needle always aligns along north-south direction. Okay, we can paint the north pole of the magnetized iron needle so that it will be always point towards the north-south direction. So when it floats, after some time when it stops, we can see that it takes place, like it comes to rest in the again north and south direction. Okay, yes. So next is attraction and repulsion between magnets. So you can see here, here is one magnet and here is one magnet. Okay, so what do you mean by this attraction and what do you mean by repulsion? Let us see. Okay, so if we hold one bar magnet in our left hand, as you can see in the image, and another similar bar magnet in our right hand, okay, and bring the ends of these magnets close to one another. So try to bring close to one another. Then our hands can feel the force of attraction or repulsion acting between the poles of the magnets, isn't it? Which are facing each other. So try to bring these two magnets close to each other. So what feel we get? Either maybe attraction or it might be repulsion. Okay. So when we place two magnets in such a way that the north pole of one magnet faces the north pole of the other magnet, what happens? Yes, they repel each other. Similarly, when the two magnets are placed near each other in such a way that south pole of one magnet face the south pole of the other magnet. So what happens here? Again, they repel each other, isn't it? Since north and north poles and south poles are like poles, we can say that like poles or similar poles repel each other, isn't it? If we place two magnets near each other in such a way that the north pole of one magnet faces the south pole of other magnet. So what happens here? They attract each other, isn't it? Since north pole and south pole are unlike poles. So we can say that unlike poles or opposite poles attract each other. So even you can see in the next image. So here unlike poles attract and here like poles repel. So you can see here this is a bar magnet, isn't it? As it is named here north and here is south. Okay. So take one more magnet here south and here is north. So when we take opposite, here is north and here is south. So whether it attracts or repel, it attracts. Why it attracts? Because they are unlike poles. This is north and this is south, isn't it? So now just you reverse it. Okay, you take here south and here you take north. So now whether it attracts or repel? Yes, again it attracts. Why? Here is south and here is north. Again they are unlike poles, isn't it? So these two unlike poles are again, they will attract. Okay, so come to this. So here is north, isn't it? And even here also north. So these two are like poles. Okay, they are same, north and north. So when we take two like poles, whether they attract? No, they repel each other because like poles always repel each other, isn't it? Not only north, just you take here south. Okay, south and here also you take south. So now when we bring closer like south pole and south pole, what happens? Whether it attracts or repel? Yes, it repel because again here south and south, they are like poles. So they are same. So when we take like poles to each other, it repels, isn't it? Yes. So even you can see here, attraction means when it goes south, north. And even here north and here south. So at that time it attracts. So when it comes to repulsion, south, south. Like poles it repels. So here north, north. So what happens when we take two like poles north and north to each other? So what happens here? It repel, isn't it? Yes. So here is one more activity. Okay. So just you take toy car. Okay. So take two toy cars and two bar magnets. Okay. To see what happens when we take two like poles to each others and two unlike poles to each other. So what happens? So just what you should do, you should take one bar magnet and just to suspend like on the top of the car, like two cars. Okay, so name it as A and here B. Okay, so here is a bar magnet, isn't it? And here is also a bar magnet. So here is north, south, and here is south, north. So here you can see these two are unlike poles, isn't it? North, south. So what happens when we take this B car near to the A car? What happens? Whether this car, A car, comes near to the B car or it move forward. What happens? Just you try this activity. It is very interesting. Even you can enjoy. Okay. So what happens here? These two are unlike poles. So here this and this. These two are unlike poles. So what happens? They attract to each other. These two car comes closer to each other, isn't it? So when we take like one more, like two more cards, just you remove that and you take a name as a C and D. Label this. So just you reverse it. So here is a south pole and even here is also a south pole. So when C labeled car come near to D, what happens? Whether this car attracts to C car or it moves forward. What happens? See here, these two are like poles. As you all know that what the like poles will do. Like poles will repel each other. So what happens? This D car will move. So it won't attract to the C car, isn't it? So from this what you come to know? Yes. So now let me tell you the properties of magnet. Okay. So what are the properties we saw in these activities? Magnet attract magnetic materials, isn't it? So magnet will attract only to the magnetic materials. Okay. The freely suspended magnet always rest in which direction? Yes, north and south direction. And the last one is like poles repel each other, unlike poles attract each other, isn't it? So always the like poles will repel each other, but the unlike poles will attract each other. So when you take north to north pole, it will repel each other. But when you take a bar magnet like north and south, so opposite poles, they will attract each other. So this you should keep in your mind that like poles repel each other and the unlike poles attract each other. Okay, so this is the important like property of magnet. Okay, so next we will see uses of magnets. Okay, so where the magnets are used. So it is used in a compass to find the direction, as we all know, isn't it? Where the magnets are used? Magnets are used in a compass. So for what they are used in a compass? To find directions. Okay. So next, even magnets are used for lifting heavy masses of iron. So even magnets are used for lifting heavy masses of iron. So by using magnets, we can lift heavy masses of iron. Okay. So even magnets are used by surgeons. Okay. To remove steel splinters from the wounds. So even surgeons will also use these magnets. Okay. So even it is used in electric bells and telephones, and even many more uses are there of magnets. Okay. Fine. So next, a few cautions. So magnets lose their properties if they are heated, if they are hammered or dropped from height, isn't it? So you can see here, if we heat the magnet, it loses its property. If we hammer, again it will lose its property. And if we throw the magnets, then also it will lose the property, isn't it? So even magnets will become weak also if they are not stored properly, isn't it? Even we should store these magnets in a proper way. So now let us see how to store magnets. Okay. Yes. So here you can see a bar magnet and a horseshoe magnet, how they are stored. Okay. So bar magnets should be kept in pairs. Okay, so always the bar magnet should be kept in pairs. So their unlike poles should be kept on the same side. Okay, a wooden piece must be placed between them. Okay, so you can see here, this is a wooden piece that should be kept in between the two bar magnets. Okay, a piece of soft iron should be placed at their ends. So you can see here a piece of iron that is placed at their ends. So why we are doing like this? To store a bar magnet, isn't it? Yes. Even for storing a horseshoe magnet, you should place a piece of iron. So as you can see here, you should place a piece of iron across the two poles. So this is how we can store magnets. Okay, if we doesn't store the magnets, then the magnets will lose their property, isn't it? They won't work. So for that we should store magnets. Okay. Yes, and even magnets should be kept away from these materials. Which are those? Magnets should be kept away from speakers, CD, television, music system, computer, etc. You can see here, you can see on the image like on your screen, mobile screen. So these are the materials from which we should keep the magnets far. Okay, we should keep far a magnet from these materials. Okay, so this is all about fun with magnets. Hope you all enjoyed this class. Okay, so just try to do all these activities. Okay, thank you.